Okay, we've been talking about nucleophilicity, basicity, thermodynamic property, kinetic property, pKa, acid and bases. Some of you probably forget already why we talked about this in the first place. Why are we interested in nucleophilicity and basicity of a reagent? All right. So we've been determining strong or weak, base or nucleophile. Why do we do that? Well, it helps you determine what route, what mechanism your reaction gonna go. All right. The reagent gonna be either strong or weak reagent. Nucleophile, electrophile doesn't matter. Nucleophile or basic or base doesn't matter. One of them gonna be strong or weak. There are only two options. All right. So the strong one, if you know that your reagent is strong, your option going to be either go SN2 or E2 because these two mechanisms require strong reagent to facilitate that either backside attack or beta elimination that happen in one step. If your reagent is weak, the option going to be go either SN1 or E1. See that? It tells you, it eliminates many options, right? And for example, iodide, strong reagent, gonna go SN2. Hydride, gonna go E2, strong reagent, right? And it will be something in between, like hydroxide can go either SN2 or E2. But we have to talk about other factors again, right? So I categorize all the nucleophiles and bases you have seen before into 4 categories. The one that only do as a base, all right? Because this guy a weak nucleophile. Hydride too small. Tetrabetoxide is too strictly hindered, right? This is too strictly hindered. This guy a strong base but weak nucleophile. All can do just an E2. If you use this reagent, you 90% sure that you're gonna get an E2 product, right? Eliminate all other options. Now we have those who are strong nucleophile but weak base. All the conjugate acid of this guy are really strong acid. Hydroiodic acid, hydrochloric acid, those are strong. Make this guy really weak base. Well, what else can it do? It can be only the nucleophile, right? And this guy are big enough to be a strong nucleophile. This guy really strong. So if you use this reagent, sodium iodide, sodium bromide, sodium chloride, or lithium, potassium, whatever of this guy, you are almost 100% sure that you're gonna go SN2. Okay, there will be some problem that hydroxide, like sodium hydroxide, sodium methoxide, sodium ethoxide, potassium, whatever, lithium, put on it. They can do both. They are strong base and a strong nucleophiles, so it can go either SN2 or E2. And we also have the weak. No matter what, they're gonna be weak bases, weak nucleophiles. Right here, they'll go either SN1 and E1. Okay, so we're gonna use this to help you predict the mechanism and predict the product, the major product. All right, let's let me check real quick. So let's do some practice together in here. Okay. All right, now I want you just to look at the reagent, just the reagent, and see what mechanism it will go. Don't have to look at the alkyl halide yet. We'll have to talk about alkyl halide a little bit later. All right. Look at the reagent, sodium sulfide. All right. Strong. So your option gonna be either SN2 or E2. All right. Strong reagent gonna go either SN2 or E2. Now, which one is that? Well, sulfide is in a group 3. This guy will do only SN2, right? Because this guy is a weak base. And so your option gonna be just an SN2. So almost 100% sure that A gonna go SN2 reaction. That's how we do it. All right. Now B, sodium hydride. So this got negative charge on hydride. So this is a strong reagent, right? Strong reagent do 2 things, SN2 or E2, either way. But which one or both? We have to look. Is hydride a good nucleophile? No, hydride is too small. It's unpolarizable. It's not polarizable. Too small to be a good nucleophile. But it's a strong base. So almost 100% sure that this reaction is going to go just an E2. Okay. All right. C, look at just the sodium hydroxide, right? Just sodium hydroxide. Strong reagent. All right. So strong reagent either go SN2 or E2. But which one though? Well, hydroxide is strong base and strong nucleophile. This guy can do both. So we need other factors to decide which one it will go. Or SN2, actually SN2 and E2 are competing. Actually, they are competing, and we have to look at other factors. Which one gonna go? Okay, so either way works. Now, water, weak reagent for sure. So weak reagent either go SN1 or E1. That's it. By the way, you see the heat right here? It's E1, elevated temperature. All right. So weak reagent either go SN1 or E1. Most in the regular condition, like room temperature, SN1 is favored, but at elevated temperature is E1. We get there. We'll get there. Okay. All right. DBU. If you still remember DBU, leave it for now. Leave it for now. We will get back to it. All right. Okay. All right. Next one, we're going to look at the structure of alkyl halide. This one going to help you as a tiebreaker. Okay.